everybody, and welcome to Mac Attack Trends in Review. Today we'll be talking about some of the malware trends as well as some of the tactics and techniques that we've seen used in malware throughout 2021. My name is Jaron Bradley. I'm here presenting with my coworkers Ferdows Saljuki and Stuart Aschenbrenner. We make up the Jamf Protect detections and research team. So before we get started, what I wanted to jump into here is just a peek of what we see over the course of a randomly selected 30-day period. If you're familiar with the macOS malware family naming scheme, then you will probably recognize the majority of these malware families as all adware, with the exception of the other line at the bottom. Adware is dominant in the macOS malware families, and we quickly saw malware adapt for M1 laptops this year. In some ways, we saw it adapt quicker than legitimate software would. Pirate and Klimply being at the top of the list here as two of the most abundant families of macOS adware. One thing you might notice is that Shlayer appears a little lower on the list here. If you're familiar with Shlayer, you know that it's one of the more common macOS adware families to run into, and it's kind of odd that we have it this low on the list. But one of the things you need to keep in mind is that this is a list of what we're seeing in real time. So a lot of times we end up getting sensors installed after malware has already been installed, in which case Shlayer is a dropper of adware, and it drops adware onto the system. So if we were to be installed after Shlayer ran, we would pick something up like Pirate or Klimply or Maxoff or Deal or something like that, which could explain why Shlayer is so low on our list in terms of what we're seeing on a regular basis. Now, some companies are okay with adware in their environment or potentially unwanted programs, pups, in their environment. And we're going to get into some of the more intense malware and some of the more advanced malware further into this talk. But we'd be skipping something if we didn't at least give a quick mention to adware, just with how purely abundant it is. And the problem with adware, there's multiple problems with adware, but first off, it's annoying and distracting. It distracts users from accomplishing work. It has no incentive to be written well, which can lead to pretty bad bugs and boggy systems. It's very invasive, so it spies on users, and it monitors their trends and their web browsing activity sometimes, and we have no idea what's being done with that info after it's collected. It's more than capable. Authors are finding and using 0 days. More on that coming up. But it shows that the authors of adware even are pretty familiar with the internals of macOS. And lastly is the level of success it has. Now, this is more of a philosophical problem, but perhaps the biggest problem in that the campaigns that adware is running, usually social engineering campaigns where they convince people to download and install it, are very successful. And you can imagine if an adware author is able to get something to run on your system without you knowing it, then some of the more advanced attackers or government entities or other things like that, they're definitely going to be able to do the same thing, perhaps in an even sneakier manner. When it comes to adware making it onto systems, what you're looking at here on this slide is just a fraction of the names that we see from a single family. Most of the time, the way these adwares get onto systems is that they disguise themselves maybe on torrent sites or other sites as pirated, cracked software that you can get for free. In reality, you download and install it, and you'll probably end up with adware running on your system. Maybe you'll end up with the cracked software too. It's a toss-up, but a lot of times you'll just end up getting hit with adware. The other place where we see this a lot is in Adobe Flash Player, rather I should say fake Adobe Flash Player scheme. So a user browses to a website to maybe watch a pirated video or something that's currently only in theaters that they want to watch for free, and the website says, "Hey, you have to install Adobe Flash in order to watch this." and the user installs Adobe Flash, and they end up with adware. It's not actually Adobe Flash. So Adobe Flash has been end of life for a very long time. So if you ever are asked to install it, I can assure you it's very likely not what you're installing. One of the big offenders of doing this is the aforementioned Shlayer malware, which I will now pass off to Stuart to have him talk about.
All right, thank you, Jaron. So here is Shlayer, and you can insert your favorite Slayer guitar riff or drum solo here. But Shlayer is one of the most prevalent, resilient, ubiquitous families of malware that we've seen in the wild, and is no exception to the typical adware techniques. It's one of the primary offenders of what Jaron just spoke to, which is infecting its users through fake Adobe Flash Player installers and or cracked software. So once downloaded and the contents of the DMG are clicked, it runs a series of commands and frequently culminates in the dropping of some type of adware, such as bundler or adload. And Shlayer is really just there to be the dropper and is the vessel passing along this adware. And even though we've seen mock-Os used to infect, quite often we see it used in scripts. And interestingly enough, some AVs don't scan script execution, which can allow it to go undetected. Shlayer is quite crafty and is utilized very many different ways to get onto end user systems. And I think of Shlayer as the basketball here being controlled by Stephon Marbury. Shlayer has continually tried different obfuscation techniques to evade detection. So how does one get infected? As you may have seen in that opening intro video, once the malicious fake Adobe Flash Player DMG or disk image is downloaded and mounted, the user will typically be greeted by some type of walkthrough, as you see here. This will instruct the user the different steps they can perform to bypass Apple's first line of defense, which is Gatekeeper. So here, after right-clicking and opening, in the background, Shlayer will begin executing commands that are typically in a bash script. However, this technique isn't the only one we've seen Shlayer use. More recently, we've seen the fake installer used in a 0-day, where the user only had to double-click the installer to become infected. And this installer had the ability to bypass Gatekeeper. So in a recent CVE, when a user clicked on this application bundle you see, it would launch a script without being checked. And there's actually going to be a JNUC session going into more detail surrounding this now patched vulnerability and the discovery of it. So check out Jamf's own Jaron Bradley and Objective-C's Patrick Wardle in a talk titled All Your Macs Are Belong to Us, the story of CVE 2021-30657, and that will be streaming on Thursday at 11 a.m. Eastern. So although we've seen Shlayer also use Python scripts or mock-Os to do its dirty work, we're going to focus primarily on bash. And one of the prevalent commands that Shlayer uses is this OpenSSL command. And it has actually become somewhat of a trademark of the malware. So according to its man page, OpenSSL is a cryptography toolkit for implementing TLS network protocols. And Shlayer actually has a few different iterations for infecting users, not just this, but a lot of them do culminate around using the OpenSSL command and passing it some type of password. So as you see in line 4, just a single line of bash code used to infect the user, but Shlayer actually has a few different styles of doing this. If we jump further down, we can see that they have assigned variables to the capitalized letters or characters of the string OpenSSL, then pass in those variables during the eval statement. Furthermore, we can see Shlayer also use completely different characters as the variables, not just the same ones in their capitalized form. Or lastly, they've been known to base64 encode different parts of the script and then decode it at some other time. This does show us that Shlayer is continuing to adapt, change, and evolve. Another way Shlayer likes to infect its victims is using funzip. So what will happen here is Shlayer will first tail the last n number of bytes, in this case 9,197, and these actually lie within a resource fork, which we'll get to a little more in a second. It'll then pipe this data to funzip and decompress the password protected files, and which is the malicious payload. It'll write those to a temp directory. It'll then update the permissions to execute and then run them in the background using NoHub. The use of a resource fork is an interesting approach. Resource forks, which are a kind of named fork, are traditionally used to store metadata like thumbnail images or things to that effect. This data is stored as an extended attribute under the key com.apple.resourcefork. And if we look here at the extended attributes, which are signified by the @ symbol, we see that the install.command script does indeed have quite a large resource fork at that. And this is because this isn't just storing a thumbnail image, it's actually storing the final malicious payload there as well. We've seen a couple different iterations of this funzip technique. In this instance, instead of using a resource fork, Shlayer has zipped the executable, or a zipped executable, which is the final payload, at the bottom of the script here. And it will then execute all of the commands on line 3 in that very specific order in order to infect the user. So thankfully, we have been seeing Apple take more action against Shlayer through XProtect, which is Apple's built-in AV that detects threats via Yara signatures. And fortunately, Apple has had an eye on Bundler, the adware, for some time, but now they're also preventing this specific Bundler dropper, Shlayer. And with the addition of a new Shlayer rule in version 2142 in March, Apple then re-upped and added 3 more rules less than a month later to version 2144. One of the tricky parts about Shlayer is that we've seen it both signed and notarized, meaning variants of Shlayer are still trying to and actually are getting past XProtect. So what are we doing to try to guard against it? And that is coverage. We provide coverage over Shlayer in a variety of ways with YAR rules that prevent both a Mako binary and a script to behavioral analytics that will detect the many ways Shlayer works to get around Gatekeeper and infect the user. We'll be continuing to watch Shlayer and monitor its changes and prevent it in the future. But for now, I'll pass it back to Jaren, who's going to speak about a very interesting piece of malware called Silver Sparrow.
Awesome. Thank you, Stuart. So Silver Sparrow was the first big Mac malware story of the year. And before I get started, I'd like to shoot a shout out to Matt Benyo for doing a lot of research on our side into Silver Sparrow. So Silver Sparrow is a piece of malware that was discovered and reported on by Red Canary back in February. When the Silver Sparrow story dropped, it spread quickly through the admin community and tech media, especially because of its strange and notable features. So what are these features? Well, first off, it was one of the first examples of Mac malware that was compiled with a universal binary. That is, the author made it to run on as many Macs as possible, right? You have your new, at the time especially, M1 architecture and the old Intel architecture, and using a universal binary and compiling for a universal binary allowed it to run on both of those. It spread incredibly fast, no less than 40,000 Macs in a matter of months, which is very, very quick. It called back to a command and control server, but had no apparent payload, and the app that was installed was more or less a dud. It didn't do anything, which again, very strange. I won't go as far to say that these details were red herrings, but the oddities of these details made it easy to overlook the novel tactic that was used by this malware, and that was the installation method in which it used was just very uncommon. Let's dig into that now. So this is a simple PKG installer, and this is what ended up on 40,000 Macs. It's unclear what its initial pretense, how it originally got onto systems. We don't know where it originally came from. Could have been as easy as a fake flash updater, just like we've always seen, or it could have been something else. But we like to take a look at these tools using a security program called Suspicious Package that lets you dig into PKG files. So when it came to this PKG file, one of the reasons it might have been installed so easily and not thrown any prompts to users is because it is in fact signed by, at the time, what was believed to be a legitimate developer. But after Apple saw that this developer had written some type of malware, they revoked that signature. And now whenever this PKG gets installed anywhere, it should no longer work. You should receive a warning that says, no, you're not allowed to install this. This is due to the developer program that Apple has. When you sign up for a developer certificate, you can get one for $99. And then you sign your software as a developer with that signature. Like Stuart had mentioned, Shlayer had managed to find a way around this whole process to do it for free, but normally this is how attackers can sometimes get around Gatekeeper and go uncaught for a while, is by having a legitimate signature until Apple discovers that they're abusing it. Note that this suspicious package tells us that there are no installation scripts, which is very strange. This is an installer package and it has no installation scripts associated with it. We also get a warning that says some logic's going to be performed before the installation occurs. Suspicious package tells us that warning, which is, again, a bit of a stranger warning. If we use suspicious package to look at the PKG, we see that it is not lying. There are no install scripts. So what is it actually doing? Well, if we go into the settings and we enable to display the distribution file, this is where the good stuff is all actually happening. We kick this over and we actually see that there's a whole slew of logic in here. The distribution file is all done in XML, which can for sure be an eyesore and painful to look at, but it is indeed a usable file where you can include some checks and some different code. So if we kick it over to the Apple developer pages and we look at the distribution file, sure enough, we do see that there's something called installation check. Now, the installation check in a distribution file is supposed to be used to perform some checks like maybe what version of Mac OS is this computer running, or what version of whatever software is this computer running. You're supposed to be able to use it to perform a couple different checks. It runs as a basic user, and you're just supposed to be able to use it to recon the system a little before you install your software. However, what the attacker has done in this case is used it to actually perform the installation. So if we take a look at the distribution file, we can actually see the installation check, as Apple calls it, and it's pointed at a function called installation check. That installation check is defined by the developer, or in this case, the attacker. All it does in this case is runs a bash command. It's set up to take an argument. That argument gets passed to bash and then executed at the shell. So what the attacker does is they design they create a launch agent that will run at startup. They do it by running the plist buddy command and creating it one line at a time. And ultimately, it's going to reach out to a URL for a stage 2 payload of some type. Now, the big oddity was that the stage 2 wasn't anything, there wasn't anything there. There wasn't anything coming down. It wasn't anything malicious. It was simply a dead end. So 40,000 systems and no final payload. Very strange, very much a question mark. We don't know exactly what the intent of this malware was, and we might never know, but we do know that it was very peculiar. A quick note, if you do ever see a pop-up like this, that means this type of installation check is being performed through the distribution file. When you install a program, you'll get this pop-up. This was even happening at the time this malware came up, but people were still allowing it and clicking through it. So just something worth noting. If you see a pop-up like this, maybe just take a second and play with the PKG a little, open it up, see what it's actually doing. This is the application that ultimately ended up getting dropped. Any developers who are familiar with Swift UI probably know that this is like the basic skeleton for a Swift UI project. It seems like the developer just did not modify it at all and was okay if there was a UI. It was just rather strange that it was hello world and not modified at all. So again, a very puzzling situation, but at the same time, a very real concern that it ended up on 40,000 systems somehow. I am now going to pass it off to Ferdaus, who will talk about a couple different families of malware.
Thank you, Jaren. So XSET is a very interesting piece of malware that is designed to steal various information from its victims. It has an impressive number of modules that give the author access to many different features on the victim's system. One of the very notable features of XSET is that it aims to infect the supply chain by infecting and spreading via developer projects on GitHub. So this is a malware that primarily targets developers. So XSET was discovered by Trend Micro in August of 2020 and infected various GitHub repos and Xcode projects. And the way it infected these Xcode projects, it would contain a hidden folder within the Xcode project containing a malicious Mako executable and a script. And upon compiling the Xcode project, the script would invoke this malicious Mako executable and infect the victim's computer. XSET is known for its use of AppleScript modules. It's capable of stealing almost anything off the disk, and it has some built-in automation for stealing specific data such as notes, cookies, local app data, etc. And it has many other modules, including some ransomware capabilities. So you can definitely consider XSET as living off the land and using that AppleScript built-in scripting language developed by Apple. And just to mention, this was pretty high on Apple's radar. Apple released several XProtect rules to detect variants of XSET. Trend Micro identified 2 0 days. The first is to steal Safari browser cookies. This essentially steals cookies via flaw in the behavior of data vaults. The second is to bypass prompts to install a developer version of Safari. And this essentially allowed the attackers to hijack Safari and inject various JavaScript payloads. The third vulnerability, the TCC bypass, which was discovered in XSET malware earlier this year by us, which we'll be going into a little bit more detail. So what is TCC? TCC is also known as Transparency, Consent, and Control. It's a security feature built into macOS that requires applications to request explicit permission from the user when accessing sensitive system resources. So this is the prompt that you typically see when an application is trying to access screen recording permissions or any other permissions. And the user would typically open system preferences, allow it, or deny this. So XSET managed to find a 0 day to bypass this prompt altogether. So now kind of going into the TCC bypass 0 day, the malware first looks for a list of applications that request screen capture permissions. These are applications such as Zoom, WhatsApp, Discord, and Slack. The malware refers to these as donor apps. XSET then goes to invoke a function called verify capture permissions, where it searches installed apps for these granted permissions. Upon finding an application installed on the victim's computer, it would piggyback off of the existing app's granted permissions. And this is not limited to screen recording permissions. We've actually tested and verified that this was also applicable to microphone, webcam, full disk access permissions, so long as these are already granted to these applications. And the app celebrates when finding a donor app, which is very common with POC exploit code. So now to kind of illustrate how this all works, the malware first curls the malicious screenshot module in memory from the C2. They then run the Apple's OSA compile command on the screen capture the Apple script, which generates a new malicious application. Inside the application is an executable called applet, which when executed will load the malicious Apple script. And the attacker then signs the malicious script as ad hoc, and this is required in order for the exploit to work. So XSET looks to see if it can find the donor app, and in this case, it finds the Zoom application. As we already know, applications such as Zoom already have the screen recording permission in order to share your screen. So the XSET malware then places the malicious applet into the Zoom directory and is now able to bypass TCC and inherit the TCC permissions that Zoom is already holding. So now to kind of go through some of the interesting commands we've discovered in the AppleScript modules, The do shell script is essentially the Apple script equivalent of executing a shell command. And in this first command here, we see that they're using the malware authors are using curl to upload screenshots to the command and control server. And they later delete these from the victim's computer, and this occurs in an interval. So they're using the -f command line argument, which lets curl emulate a filled-in form, and the file gets attached in the post request as a file upload. And of course, in this case, the malware is uploading screenshots, but of course they can choose to upload any other file if they chose to do so. In the second command here, similarly, the malware is using the -d to upload specified data in a post request. And along with various other arguments, -a specifying x-user and x-module from the victim's computer. And this essentially allows the malware to, or the victim to check in to the C2 and indicate that it is alive. And finally, we've seen curl or exec use the -k and s command line arguments. -k allows curl to proceed and operate for insecure server connections, and -s for silent or quiet mode, making curl mute. And finally, the OSA compile command specifying -x as the command line argument. You can save the resulting script as execute or run only, making it a lot more difficult to analyze the source code. And of course, -o, you can output the compiled Apple script as an application. So now we're going to shift gears and talk about something that isn't a piece of malware, but rather a red team pen testing framework. So the reason we've chosen to include this in our talk is that malicious actors are known to use well-built frameworks to save time and to effectively accomplish their objectives. And of course, Mythic is no different. Mythic is an open source red teaming framework developed by Cody Thomas and various other developers. It's available on GitHub, and it has various cross-platform capabilities supporting macOS agents, developed on Python, Docker, and it also has a web UI. So now the command and control server consists of various payloads, C2 profiles, configurations, and callbacks. So you would first generate a payload within the Mythic UI, and you can configure various profiles and also configure redirectors, encryption, specify built-in commands, so on and so forth. And you can get the payload onto your victim however you choose to do so. And once your victim actually runs the payload, you get a new callback within the Mythic UI. And you, of course, can manage these callbacks and along with various other information, just such as the IP, last check-in, execute shell commands, and various other modules. Now, to kind of illustrate how this all works, each payload type and C2 profile is in its own Docker container, allowing it to have its own operating environment. And each Docker container has a Python service running in it that connects to a RabbitMQ message broker to receive its tasking. So you can have several operators via different browsers where they could manage their victims, execute shell commands, other modules, or even establish persistence as necessary. Each Docker container sends a heartbeat every few seconds to the main Mythic server to indicate it's still up and running, as shown by the green. On the left here, we have various payload types, and on the right is some of the C2 profiles.
Thank you, Sal. So in conclusion, adware is still leading the market when it comes to malicious activity on Mac OS. And over the years, the threat to Mac users has grown as we're seeing more sophistication from those who are attacking it. So details from both our findings earlier this year on Shlayer and XSET can be found on our Jamf blog. And thank you so much for joining this talk, and enjoy the rest of your JNUC.